Hello. Today we're going to solve two problems that involve finding the maximum of a quadratic function. So let's read our first problem. It says a ball is thrown across a playing field from a height of h equals 3 feet above the ground at an angle of 45 degrees to the horizontal at the speed of 20 feet per second. It can be deduced from physical principles that the path of the ball is modeled by the function y equals negative 32 over 20 squared x squared plus x plus 3, where x is the distance in feet that the ball has traveled horizontally. So what we'd like to find is actually the y-coordinate of this vertex. The vertex is going to be where the parabola changes direction. So this point has an x-coordinate and it also has a y-coordinate. The x-coordinate is what we're going to find first, and we're going to use this formula here, x equals negative b divided by 2a. And recall that a quadratic function written in standard form is ax squared plus bx plus c. C is the constant, the one number that will not have a variable attached to it. B is the coefficient of the variable raised to the first power, and A is the coefficient of the variable raised to the second power. So in this case, A is going to be negative 32 over 20 squared. B is going to be 1 because there's no number in front of the variable x, so we assume that it's a 1. And C, the constant, is going to be 3. So first off, let's find the x-coordinate. So step 1 is going to be to find the x-coordinate of the vertex. And we're going to use x equals negative b over 2a. You always start off with your negative no matter what b is. We already said b is 1 over 2 times a, which is negative 32 over 20 squared. Now, we're going to use the calculator to figure out what this x-coordinate is. And I'm going to pull up my screen version of the TI-84 Plus. And I happen to have the latest operating system that allows me to enter this as a fraction. And this is a great help when it comes to entering your parentheses and such. So what I'm going to do in order to access that feature is press alpha and y equals, and you notice that these options come up, and I'll press enter and notice that it gives me a fraction. Now for the numerator, we're going to type in negative 1. Going to move down to the denominator and type in a 2 and parentheses. Now I'm going to put another fraction in there so I can type in my negative 32 on top, and on the bottom 20 squared. Now I'm going to move to get out of the cursor there. Went a bit too far. Okay, and we press enter and we get 25 over 4. And if we want to figure out what that is, we just do 25 divided by 4, and you see that we'll get 6.25. So the x-coordinate is 6.25. Now that we have the x-coordinate, that's not our answer because we want to find the height. And height is going to be the y-coordinate. So next, we'll take the 6.25 and plug it into the function. So our function is, I'll rewrite it, f of x equals, and it's just the function that we were given up here, negative 32 over 20 squared x squared plus x plus 3. And what we want to find is f of 6.25, and we will write negative 32 over 20 squared times 6.25 squared plus x, actually not x, plus 6.25 plus 3. And once again, we're going to bring up our calculator. Now, I'm going to do something here with the calculator so I don't have to keep typing in this negative 32 over 20 squared, because we are going to be using that again. So let's go back to the fraction feature, and I'm going to type in negative 32, and on the bottom here, 20 squared. And it gives us negative 2 over 25. So let's find out what that is. It's a decimal here. Negative 2 over 25, which is negative 0.08. That's actually the value of our a. And what I'm going to do is store that in a variable. And all we do is press the STO button and alpha and the letter A, and it stores it in A. I'm not going to bother to do that with B or C, because B or C, they're just pretty simple numbers, 1 and 3. So that's not going to be a problem. Okay, so let's get back to typing this in. To find f of 6.25, I'm going to do get back A, and that's going to be multiplied by 6.25 squared plus 6.25 plus 3. And we see that our y value is 6.125. So the value of f of 6.25 is 6.125. And that would go in here for A. Now, the next thing it asks us is to find the horizontal distance the ball has traveled when it hits the ground and round your answer to 1 decimal place. When the ball hits the ground, the value of y is 0, because I'm at a height of 0. So what we have to do, and this will be part B, we'll write this over here. What we have to do is set our equation equal to 0. So 0 equals negative 32 over 20 squared x squared plus x plus 3. And let's make this 2 a little better. 2. Now, the way we're going to solve this is by using the quadratic formula, which we have written here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, remember we always start with the negative, b is 1 plus or minus the square root of b squared, 1 squared, minus 4 times a, which is negative 32 over 20 squared, times c, which is 3, divided by 2 times a, which is negative 32 over 20 squared. And we're going to plug this whole thing into the calculator. And this is where that little store function that I did before is going to come in handy. So this is a fraction. So let's go once again. Alpha y equals, and we get a fraction. On top, I want to type in negative 1. First, I'll do plus. and square root, so second and x squared, 1 squared minus 4. Now, instead of typing in negative 32 over 20 squared again, remember I put that value in a, so alpha a times c, which is 3. Move down, divided by 2, and once again, alpha a, and we press enter, and we get negative 2.5. So that's one answer. Let's get the second one. And the second one, I'm going to use another shortcut. And in order to do that, I'm going to use this function, second enter. You see what that does is type in everything that we just typed in the previous calculation that we did. And I don't want to have to type the whole thing over again, so second enter gives me that back. And all we have to do is move the cursor over to the plus sign and change that to a minus sign. Press enter and we get 15. So there are two places where y is equal to 0. One of those is negative 2.5 and the other one is 15. We're going to use the 15 as our answer because a distance cannot be negative in this case. So our answer for part B is going to be 15 feet. All right, we're going to do another problem where we're going to use the x-coordinate of the vertex and the maximum. It says a rain gutter is formed by bending up the sides of a 50-inch wide rectangular metal sheet as shown in the figure. And you can see it's a rectangle and it gets bent up. This is the width, and we make a little channel by bending it up. Now, this is what the sheet looks like flattened out. The width, we know, is 50 inches. So the width is 50. They just showed us in the diagram above that they're going to take this distance of x and this distance of x and fold them up. Now, if they do that, you would have to subtract x and x. Therefore, this distance from this point to this point is going to be the whole 50 minus both of these x's, so 50 minus 2x. So this distance right here, this width, is equal to 50 minus 2x. Now it says find a function that models the cross-sectional area of the gutter in terms of x. We know that area is equal to length times width. Now the length we'll use here is x, that's this distance here. So x times the width we just found to be 50 minus 2x. And we're simply going to distribute the x here and the x here. In doing so, we will get 50x minus 2x squared. So our expression for the area is going to be 50 minus 2x squared. Okay, so that's our part A. Part B asks us to find the value of x that maximizes the cross-sectional area of the gutter. And we're going to use the formula that we used in the previous problem, x equals negative b over 2a. So let's write x equals negative b over 2a. We're going to use that on this function here. Now, you do have to remember two things. B is the number that's in front of the variable raised to the first power, while a is the number that's in front of the variable raised to the second power. So this is not exactly written in standard form. Our b is actually 50, and our a is -2. So let's plug those in. So x equals, you always start off with your negative. B is 50 divided by 2a, or 2 times -2, and -50 divided by 4 is -12.5. Actually, I stand corrected. A negative divided by a negative is a positive. So positive 12.5. So the value of x that maximizes the cross-sectional area of the gutter is positive 12.5. We know that it couldn't be negative because the distance we're looking for cannot be a negative value. Now, the last part we have to do, C, is find that maximum cross-sectional area for the gutter. And all we're going to do is find out the value of A when we plug in the x value of the coordinate 12.5, the x value of the vertex. So to figure this out, A of 12.5 equals 50 times 12.5 minus 2 times 12.5 squared. Okay, and we're going to go right back to the calculator here. So 50 times 12.5 minus 2 times 12.5 squared. And we get 312.5. So our area is going to be 312.5 square inches. Okay, I hope this makes the x coordinate of the vertex and the maximum of a quadratic function a little bit clearer to you. Thank you.